Hi there, this is video 719. We're going to look at the x-intercepts and we are going to calculate them. And our starting point is going to be the vertex graphing form. Now, with the x-intercept, you can have no x-intercept. See how this one doesn't cross the x-axis? Or you can have exactly one x-intercept right there, or you can have two. It all depends on what the equation looks like. Remember, with y-intercepts, there's always one. Now, in the last video, I taught you something really important. I said y-intercept, x equals 0. So by the same token, when you're looking for the x-intercept in something, y is going to be 0. So that's important to remember. Now, if the equation is in the vertex graphing form, you can substitute for y. You can put a 0. You can just do a left little substitution, and then you can solve. Now, we have confession time. It's been a while since I've done these, so I'm going to flip over to pencil. So 0 is equal to 4x plus 7 squared minus 16. Now, if you remember, when you solve any multi-step equation, you're doing SAMDEB, or basically your regular order of operations backwards. So we are trying to get that x all by itself. So the first thing I want to do is move the 16 over to this side. So 16, sorry, add 16 is equal to 4 times x plus 7 squared. So that was our subtraction. There's no addition left over here, but we do have multiplication of bits, so we want to do that. So then we get 4 is equal to x plus 7 squared. Now, that part you should have been able to do with no problems, because there's nothing weird that was going on. I think you even should remember what happens now, because if you've done the trig section, and I know you should, because that was like chapter 2 or 3, you're used to solving with square roots. So take the square root of each side, and we get 2 is equal to x plus 7. But here's the weird thing that happens, is this specific parabola actually has 2 x-intercepts. And there's something that, truthfully, we never talked about when we did, or if I did, it was just just tangential. That's terrible. Tangent. As a tangent, so as kind of like a, hey, you should know this. It's not really important right now. Well, now it becomes important. When you take the square root of something, you actually get 2 roots. Okay, let me just, I'm going to go over here. Let's just say we had 4 is equal to x squared. I'm going to forget about 7 for a second. If that was the equation, we would take the square root, and we would go x is equal to 2. And 99% of the time, that's all you need. That's done. It's perfect. We're good. But the real truth is, if we go backwards, 2, if we square 2, I'm squared, like I'm going this direction now, 2 squared is 4. But you know what? So is negative 2. Negative 2 times negative 2 makes positive 4. The long and short of it is, there's actually 2 roots when you take a square root, 2 answers, but we usually deal with what's called the primary root, but it's the positive one, because most of the time the negative one doesn't help us. Anyway, getting back to where I want to be, at this point, what you do is you split and you go 2 is equal to x plus 7, or minus 2 is equal to x plus 7. And then you just solve those 2 mini equations. So we subtract 7 here, subtract 7 there. 2 minus 7 is minus 5 is equal to x, or subtract 7, or minus 2 minus 7 more is minus 9 is equal to x. So my x-intercepts are going to be minus 5 and 0, or minus 9 and 0. That's how you can get in a question like this one, where you've got the 2 roots. Okay? All right, let's try that again. because the process, once you do it a few times, is actually becomes really easy. Some of these ones on the bottom part, I've thrown in some, not trick questions, but I just wanted to see what happens, because it's not always going to be 2 roots. Sometimes it's going to be just 1 root, and sometimes it's going to be no roots, no x-intercepts. So I want you to see what that kind of a question looks like as you work it through. All right, you know what? If you're feeling brave, why don't you turn off the video and try this one, or maybe even that one by yourself. Okay, and I trust you did that. So I want to get this x by itself, so I'm going to start by moving the 15 over. So I've got minus 15 is equal to minus 5 x minus 2 squared. Now we'll divide minus 5. So we get 3 is equal to x plus 2 squared. And then we do the square root thing. Oops. So why am I done so much? I forgot the step to put the 0 in there. My bad. I'll remember that on the next one. I'm going to square root. I'm going to square root. And on this side, I know I'm going to get x plus 2. I don't know off the top of my head what the square root. You can almost see it. Square root of 3. So let's go square root 3. There. Equals. Okay, so it's 1.73. Because we're talking about graphing, 1 decimal place is more than enough. So 1.7. So I go plus or minus 1.7. So once you do that, you have the plus minus. That's when you do your split. So 1.7 is equal to x plus 2, and minus 1.7 is equal to x plus 2. And I don't care whether you write the or in there, but that's when the split happens. So subtract 2, subtract 2. 1.7 minus 2, I can't believe there's a point there, negative 0.3 is equal to x, or minus 2, 3, negative 3.7 is equal to x. The nice thing about being able to calculate the x-intercepts is they're not always going to be set where, like this one, where it's really easy to tell. I mean, that's 0, 0, and that's minus 2 and 0. What do you do when your parabola looks like that? Right? Then you're trying to estimate where those things are. Is it half? Is it, or I can make it even worse where it gets, I don't know what that is. I know it's somewhere between minus 1 and minus 2 and closer to minus 2. I don't like that in math. That's not good enough, not approximate. We can actually calculate them out to a high degree of accuracy. So give it a shot. Now, how about you try this one? This one actually is really easy. So remember to put my 0 in there. 9x squared minus 25. And the reason, again, is when you're doing the x-intercept, y is equal to 0. So we can do that cool little substitution. Plus 25, plus 25. And I'm going to get 25 is equal to x squared. Whoopsie, 9x squared. And then we divide by 9, divide by 9. So x squared is equal to square root. Okay, I was about to do it old school. We can do 25 divided by 9 first. Excuse me. And that gives us 2.8. When you go 25 divided by 9, 2.7 repeating. So I just went to 2.8. Then we take the square root, square root, square root. And I get 1.6 repeating. Oh, but I just trust, you guys can trust me from now on. I'm going to stop showing you what it shows me. So I got plus or minus 1.7 is equal to x. And now we do our split. So 1.7 is equal to x, or, oh, that's pretty easy. Negative 1.7 is equal to x. Because there wasn't anything with the x squared, like here we always had that minus 2 or the plus 7, we had to do more. It was just plain old x squared. Ta-da! We're done. How's it going? See, it looks scary, but after you've done a bunch, it's like, oh, okay, well, that's pretty straightforward. Let's look at these last ones. All right. Oh, okay, so why am I sighing? Why am I thinking? Same start as always. So 0 is equal to minus 2x plus 1 squared. Well, there's no number back here to move over, so there's no addition and subtraction to do. So I guess I'm going to divide by minus 2. Divide by minus 2. Oh, this is boring. 0 is equal to x plus 1 squared. Now, don't get weirded out. You can take the square root of 0. I'm very curious now. Yeah, minus 0. I thought maybe my calculator might give me something different or weird or an error, but nope. Just as I thought, the square root of 0 is 0. So plus or minus 0 is equal to x plus 1. I know they mean the same thing, but it's okay. Don't change the plan. So we got 0 is equal to x plus 1, or, do it right, minus 0 is equal to x plus 1. Plus 1, plus 1. So x is equal to 1? No, negative 1. Sorry. Negative, negative, negative. Minus 1, minus 1. So this looks, oh, I just realized how bad I'm being here. I'll go fix it here. This isn't wrong. What this is showing us, just hold on while I move this, is an equation like this one. Oh, in fact, it is this one, this very exact equation, where, okay, you get two answers, you get two x-intercepts down here, but the truth is they're exactly the same, so if you were to graph it, it comes out at the same point. So this is what happens when you have only one x-intercept. You get the square root of 0. Okay, so you might want to add that onto your sheet. All right, now let's take a look at the next one there. 0 is equal to minus 2x plus 1 squared minus 1. So let's add 1 and add 1. So 1 is equal to minus 2x plus 1 squared. And then we're going to divide by minus 2, divide by minus 2. So minus 0.5 is equal to x plus 1 squared. Now, this I do want to show you on the calculator. So square root, where's my negative 0.5? And boom, math error. You are not allowed to take the square root of a negative number. Well, you can, and this is what you get, unless you're in calculus or pre-calculus, in which case you will learn about a really cool set of numbers called imaginary numbers. All the stuff we've worked with so far is real numbers, but believe it or not, there's a whole set of other numbers called imaginary numbers, and they deal with what happens when you get the square root of a negative answer. But the long and the short of it is, go like this, and I think this is a good way. Can't square root negative number. So you can even write math error. I'd be okay with that, which means there's no x-intercepts. So remember, and flip it up here. And in fact, this was the equation that we were solving for. So you can see that this it doesn't have an x-intercept, and if you just do it with the equation, that's what happens. So this is kind of important. One x-intercept is here, and negative is two x-intercepts, or sorry, is zero x-intercepts. And this last one, I'm not really sure why I put it on here. I think, well, I don't know, let's see. So 0 is equal to 12x minus 9 squared plus 45. So we're going to subtract 45, so minus 45 is equal to 12x minus 9 squared. Oh, I know what I did. 5 by 12 divided by 12. I don't know, but 45 divided by 12 is a negative number. 45 divided by 12, 3.75, so negative 3.75, and no x-intercepts. I thought it might have been interesting just to show you one where the numbers were bigger, but it really doesn't matter. Like that. So you can't square root a negative number, so there's no x-intercept. So I don't know what this graph would look like. Well, I do actually. Okay. So there is, oh, look at this. This is kind of cool. So since this is in the standard graphing form, I can read my vertex. My vertex is, swap my p, so 9 and 45. So it's way, I don't know what kind of scale, but it's way up there, and it opens upwards because A is positive. So you can double check, right? I knew which way it was going to go, and you can see that with a vertex of 9 and 45, you're not going to have any x-intercept. It's never going to cross the x-axis down here. So pretty cool. Math is awesome. Have a great day.